Hello again. Today we're going to be talking about adding and subtracting in scientific notation. Your warm-ups, write 750 million in scientific notation and write 5.63 times 10 to the negative 3 in standard form. Go ahead and pause the video and you can work from there. So our first thing is we can add and subtract with the same power of 10. Okay, so in my first example here, I can see that I have 10 to the 7th and 10 to the 7th. So when I have the same power and I'm adding or subtracting, I can just add my front numbers. Let me get a different color here. Lost my pen. So because they're the same powers, the same exponent, I can do 5.11 plus 9.55, which if I add those off to the side, remember when you add decimals, you gotta line them up. 1 plus 1 is 6. Or I'm sorry, 1 plus 5 is 6. 1 plus 5 is 6 again. Bring my decimal down. 5 plus 9 is 14. So I have 14.66. And I get to keep the same power. So just add my front numbers and keep the power the same. So it's still 10 to the 7th. But I need to make sure that I am in proper scientific notation, which I'm just going to say is SN. So proper scientific notation. Okay. And this is not in proper scientific notation because if you notice the number in front of my decimal is 14, which is not between 1 and 9. So I need to move my decimal place over 1. Let's do it with this color here. Okay, so I got 1.466. And since I made it into a smaller number, I'd want to be able to go back to a bigger number here, so I need to add 1, so that's going to be 7 plus 1 because I moved 1 place over. So this would be 1.466 times 10 to the 8th. Now some of you might not write this step here, and that's fine, but if you do need to write that, that is also fine. Okay, so this would be my final answer. So when I add 5.11 times 10 to the 7th, plus 9.55 times 10 to the 7th, I will get 1.466 times 10 to the 8th in proper scientific notation. Okay. Now some of you also, you could have put this both into standard form, then added them and put it back into scientific notation. But that's just a long way of doing it, okay? My next example is some subtraction. I have 9.55 times 10 to the 6th minus 5.11 times 10 to the 6th. And again, these have the same base here, the same powers. So I can just subtract like I normally would. So I'm going to actually subtract my front numbers. So 9.55 minus 5.11. 5 minus 1 is 4. 5 minus 1 is 4. Bring my decimal down. 9 minus 5 is also 4. How convenient. 4, 4, 4. So I have 4.44 times 10 to the 6th, because again I just keep that exponent and power coming down. Okay. And this is in proper scientific notation because the 4, which is in front of the decimal, is a number between 1 and 9, positive or negative. So I'm all set. So this is my final answer here. Okay. Let's do one more example like that. This one's a word problem. So it says Wyoming has a population of 5.63 times 10 to the 5th. Vermont has a population of 6.25 times 10 to the 5th. What is their population together? So since it's together, not the difference between them, that's an addition problem. So I'm going to have 5.63 times 10 to the 5th plus 6.25 times 10 to the 5th. And again, they still have the same power, same exponent. So I can add my front numbers, so 5.63 plus 6.25. That's 8, 8, and 11. So I have 11.88. And then again, I just get to keep that exponent. Now, if you notice, that is not in proper scientific notation because 11 is not between 1 and 9. So I need to move my decimal over 1. So I get 1.188 times 10 to the 5, and I'm adding one spot over there. So that is going to be 1.188 times 10 to the 6, and that would be my final answer there. Sorry, you can kind of see the next question coming up. Okay. So this, the easy part, is when it's the same exponent power. The little bit more difficult part is when I have exponents with different numbers in them. Okay. Sorry if I'm going kind of fast. I see my time is going pretty quickly. So my next section is when I'm adding and subtracting with different powers. Okay. So in my first example here, I think it's the only one on this page. Notice I have 10 to the 7th and 10 to the 6th. I cannot add and subtract them if they do not have the same exponent power. Okay. So I need to make them look like the same exponent power. I can do this two different ways. I always make my bigger one smaller because that's easier to do, but you could make the smaller one bigger. But I'm going to make the bigger one smaller in this case. So if I rewrite 6.4 times 10 to the 7th is really 10 times 10 to the 6th, because remember if I added, there's an invisible 1 here, 1 plus 6 is 7. So I can break that up. I'll just bring this 5.4 times 10 to the 6th along for the ride. I'm just going to put these in parentheses so you can kind of see what's what here. What's together and what's not together. So now 6.4 times 10, because I just wanted as something times 10 to the 6th. 6.4 times 10 is just 64. And I bring down that 10 to the 6th. Plus 5.4 times 10 to the 6th. Now I do have the same exponent power. So now they're both 10 to the 6th. Okay. So now I can do 64 plus 5.4 just like I did earlier. 0 plus 4 is 4. 4 minus 5 I have to borrow. It gives me 9, 59. So I now have, oh, I'm sorry, this is addition, not subtraction. I apologize. Ignore that last part there. So that was subtraction, that was what I would be doing. So 64 plus 5.4, goodness, 0 plus 4 is 4. 4 plus 9, 4 plus 5 is 9, and then 6 plus 0 is that, and I bring my decimal down. So I'm sorry, I mixed my adding and subtracting all together there. So I get 69.4, and again I just get to bring down that exponent because it's adding, so it's the same idea. Okay, so once you change the base to look the same, then you can add like we were doing earlier. Okay, one more example. What side is that? So we're on this one. So it says the approximate area of Australia is 9 times 10 to the 6th kilometers squared. The approximate area of Antarctica is 1.37 times 10 to the 7th kilometers squared. What is the difference between the two areas? So difference means subtraction. So I'm going to do bigger minus smaller. So I'm going to have 9 times 10 to the 6th minus 1.37 times 10 to the 7th. And I'm sorry, we're actually going to write bigger minus smaller here. And 10 to the 7th is bigger than 10 to the 6th, remember from our comparing fractions. So 1.37 times 10 to the 7th minus 9 times 10 to the 6th. And again, I have different base exponent powers here. So I'm going to turn my bigger one into look like my smaller one. So this would be 1.37. I can bust this 10 to the 7th to be 10 times 10 to the 6th minus 9 times 10 to the 6th. So again, this 10 and 1.37 I'm going to multiply together. So it's going to be 13.7 times 10 to the 6th minus 9 times 10 to the 6th. Okay. So now since my exponents are the same, I can actually do my subtraction. So 13.7 minus 9. And now I'm going to subtract, unlike the last time I did this. So 7 minus 0 is 7. And 13 minus 9 will give me 4. So I'm going to get 4.7. Okay, times 10 to the 6th. So I'm going to rewrite this instead of writing it there, because I just bring that exponent power down there. Okay. So that's my final answer. So when you're looking at a difference problem, and in this case it doesn't matter which one goes first because I just want to know the difference between the two. So I would do bigger minus smaller just so I don't get a negative number. And the bigger one is 10 to the 7th, not 10 to the 6th. That's what we learned last chapter. And then I get the powers the same. I do my subtraction like I normally would, and then bring down my answer. Okay. So here's your exit slip. So you need to do 3.11 times 10 to the 3rd minus 4.0 times 10 to the 3rd. Find out what you get there. And then your homework is page 79, number 1 through 7 odd, number 11, and number 13. Have a great day. We'll see you tomorrow.